Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video on types of data. So we're going to divide types of data into. Data can either be numerical, also called quantitative, or categorical, which is called qualitative. So to determine which type of data something constitutes, ask yourself, would someone respond to this question with a number or a category? So let's go through some examples. So let's say I wanted to know what's the most common hair color at Marist. So, is that numerical or categorical? Well, I need to ask myself, if I ask someone their hair color, would they tell me a number or a category? Well, they shouldn't tell you a number at all. They'll give you a category. Either they're blonde or have brown hair, black hair, or whatever. So, hair color is a type of categorical data. So let's say, for example, I asked everybody how many times a week they go to the gym. If I say, how many times a week do you go to the gym, people would respond with a number. They might say 0, they might say 5. So that would be an example of numerical data. Let's say I asked people what grade they scored in maths last semester. They would say A, B, C, D, or E. That's like a category. It's not a number. I wouldn't say, what grade did you get in maths last semester? You wouldn't say like 2. That doesn't make any sense. So, the grade for a subject is categorical. But if I asked you for your last test score, what did you score in our last maths test? You would respond with a number. You might say 80% or 78% or whatever. So if I ask you a test score, that is an example of numerical data. So numerical data is when the data you collect, the responses you get are numbers, and categorical is when the data you get, the responses are categories. Okay, so this is all well and good for types of data, but let's look at how we're actually going to collect some data. Okay, so there are a lot of words that we need to know here. So let's say I want to know how many times per week kids in Canberra exercise. So I'm thinking about kids in Canberra, how much they exercise. So every kid in Canberra, they form the population. They form the whole group of people I'm interested in. So if I were to go and ask every kid in Canberra, probably like 100,000 kids or whatever, that's called a census. That's when you ask every single member of the population. But think about this. If I want to know how many times per week kids exercise, if I want to know how much exercise the average kid in Canberra does, I don't really need to go and ask every one of the 100,000 kids in Canberra. That would take forever. Instead, what I'm going to do is I would ask a subset of the kids in Canberra. I'd ask just some of the kids in Canberra. So that group of kids that I ask is called a sample. So a sample can be biased or unbiased. So unbiased means that the sample you pick is basically good. It represents the population. I'd likely get the same results if I asked the population that I did from the sample. Biased is the opposite. A biased is when the sample's not good. It gives you like very different results than you'd get from the population. So let's say I want to know how many times per week an average kid in Canberra exercises. So I could ask just kids at Marist. So if I ask kids at Marist, that would be a sample. But see, the thing is, if I ask just kids at Marist, this sample is probably biased. The reason this is probably biased is I think kids at Marist are more likely to do exercise than your normal kids. So if I ask just kids at Marist, I think I would get a higher number of times per week that they exercise than if I asked every kid in Canberra. So why might that be biased? Well, firstly, at Marist, there's only boys. And we know participation in sports is much higher for boys than it is for girls. Another reason is if you ask kids at Morris, well, you guys are enticed to do co-curricular. You're told you have to do co-curricular. So you're more likely to exercise than your typical kid. And you can see that in the classes. I have heaps of sporty classes. If I'm just going to go and ask sporty people how many times per week they exercise, that's not representative of your average kid in Canberra. If I were to ask how many times per week kids exercise at Marist, it is likely to be much higher than if I were to ask every kid in Canberra. That's what I mean by a biased sample. If I wanted an unbiased sample, the best way to do that is random. So if I want an unbiased sample to ask how many times per week kids in Canberra exercise, I don't want to just pick people I know. I don't want to pick people who I know are sporty. I want to pick people at random. I want to get a group that's representative of kids in Canberra. So it would have, ideally boys and girls. It would have some really sporty people, but some couch potatoes as well. And another thing I would want from an unbiased sample is I would want it to be relatively large. I wouldn't want to just go and ask 2 people how often they exercise, because that's not going to be representative of your typical kid in Canberra. What if the 2 people I ask happen to be really sporty? So the way I would want to do this study, rather than asking every one of the 100,000 kids in Canberra, I want to ask a sample. I want to ask just a subset of kids in Canberra. So I would want to ask a decent number, maybe a few hundred rather than a few 100,000. And I would want that group to be randomly chosen, not just kids I know at Marist. If I picked a sample like this, it would be a good representation of your average kid in Canberra. So the last thing I want to go through is the difference between a biased and an unbiased question. So let's say I want to collect data on the issue I was talking about on the previous slide, the number of times per week the average Canberra kid exercises. So I would ask them a question. So I could ask them something like, how many times per week do you exercise? Now this is an unbiased question. So an unbiased question is one that doesn't lead the person to say a specific response. It doesn't entice them. It's just a totally non-judgmental question. If you say, how many times per week do you exercise? There's no reason to think that the people responding would give you a false answer. There's no reason to think they'd lie to you. But if I wanted to know how many times per week people exercise, what if I asked them this question? Given that people who exercise are cooler than those who don't, how many times per week do you exercise? This would be a biased question. It's leading, it's enticing the people who respond to give a higher number. If you're telling them you're cooler if you exercise more, then they're more likely to lie to you and give you a higher number. Say that they exercise 5 times a week when they only exercise 1 time per week. So biased questions are really bad because they don't give you accurate data. Now, you're probably looking at this and thinking, wow, this is just common sense. Happens all the time in the media. People ask questions like this that are leading questions to sort of get the data they want and to prove a point. But of course, you'll never be dishonest and do that because you know the difference between an unbiased and a biased question. We want to ask unbiased questions that don't entice the respondents to lie or to give you inaccurate data. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.